Okay, thank you. Our next talk for Kicon this afternoon is going to be André Alcade. André Alcade is the co-founder and vice president of strategic development at Celus. And he brings a rich background in electronics engineering to his role. He's held positions at industry giants like TDK, Delta Electronics, and Intel. André possesses a deep and expertise in hardware design and manufacturing. He is very humble. And at Celus, he leverages his extensive industry expertise alongside cutting-edge AI advancements to develop technologies. Today, he is going to be talking to us about converting schematic images into in KiCAD. So please give a warm welcome to André.
Thanks, Seth, for the introduction. Hi everyone. I'm really glad to be here today talking to you about this exciting project. We have been working already for a couple of months. So I want to discuss with you, the idea of transforming schematics images to KiCAD. And before I do that, just a couple of words about Celus. Maybe some of you already have heard about us. We're basically a startup. We were founded 2018. We're based in Munich, here in Germany. But we have also offices in Porto, in Portugal, and as well in Austin, in Texas. And we're about 100 employees now and growing. And what we do, so we're basically a software company whose mission is to accelerate the electronics design through smart recommendations. What does that mean? That can mean a lot of things. We have basically an online platform. It's called the Celus Design Platform, and we enable every engineer to go to this platform to define the requirements of the project that they are starting in form of block diagrams and in form of parameters as well. And we are able to take those requirements and recommend then, based on that, the appropriate circuits and the appropriate components for your design. So we want to help a little bit on that process of finding the right component for your design, of finding the right application circuit for that component, instead of spending hours and hours browsing the internet or reading data sheets. We want to enable a quicker development process by providing those recommendations then. And what you see here is basically just a schematic. It's just can visualize this schematic on our platform, and then you can export those results to different CAD tools, being KiCAD one of the ones that we support as well. But today, I'm here not to talk necessarily about the Celus Design Platform. We can talk about that later on if you guys are interested. But I'm here to talk about this project of transforming schematic images in real native schematic files. And the question is, why is that important? Why is that an interesting thing to do? And the thing is that if you look into all those images here, we have different circuits here that we're taking out of application notes, out of data sheets of component manufacturers. And they all share an interesting fact. They're all good, and let's say they're all useful for us as electronics engineers whenever we are, deciding to use a new component and never used that component before, so we have to figure out how to use it. But also, all of them are provided as images. And that means if we're designing a new circuit, if we want to design a PCB out of that, at some point we'll have to take those images and we have to capture them in a tool like KiCAD and then proceed with the development process after that. So that means there is a process here of looking into an image, finding the appropriate symbols in my library, and reconstructing this schematic on KiCAD in this case. The thing is that this process can be very time-consuming. So if you look into our internal teams at Celus, we have quite some electronics engineers there. They help us with the content that our platform needs to provide those recommendations I explained before. And about 40% of their time is spent by capturing those schematics. That means 40% of the time looking into one drawing and reconstructing that drawing into like KiCAD. Sometimes this redrawing includes also some creative tasks, like you may be redesigning one component or other component, redimensioning it. You may be changing it slightly so that it fits better your application. But a lot of that is also just basically copying the design to the schematics. So this time could be used to do other things as well. It could be used to do simulations. It could be used to do optimizations on the circuit. So wouldn't it be cool if we had a different way of handling this transformation from images that component manufacturers provide us to a schematic in KiCAD? So that's what I would like to propose. So think about taking a screenshot of a PDF that is provided by one of those component manufacturers, just going then to KiCAD and basically pasting it in form of schematics. I think that it would be very productive for a lot of people, not only for us. We started working on this project because that would help a lot our internal teams, but I think that this would be very productive to a lot of people working with circuit design. So the idea that we want to propose today is an open source project where whenever we have a schematic image, can take that image, can import it in KiCAD. We somehow trigger the transformation of that image to a schematic, to using the plugin that I mentioned before. So if I take here KiCAD, we have here a plugin that is integrated in KiCAD. It was really interesting also to get to talk today in the morning about plugins because I have a better understanding of what is possible, what is not. And this plugin then could communicate with an API on our side. This API is necessary because we need specific models in order to be able to extract this information out of the image. It's not something that we can just do out of the box or algorithmically. And then this API would return the information that was extracted out of the schematics back to the plugin, where the plugin can really then transform this into a real schematic file on KiCAD. So I talked about API. The API is what we have been working mostly in the last months on how to really transform whatever image we have that contains a circuit schematic into something that really contains the information about that circuit, that is not just an image. So it contains authentication endpoints, it has a conversion endpoint. It's relatively simple, doesn't need a lot of configuration, or it doesn't have 1,000 different endpoints. It receives an image, and it outputs the schematic information in form of a graph. So let me dive a little bit deeper on how does that exactly work. As I mentioned before, we start with taking a screenshot, save it as an image, contains a specific schematic that we want to extract. Now, this is just then a proposal that I have, but it would be really interesting to hear all the ideas that everyone has about how to implement that. But I thought about why not we just import this image in KiCAD, just like an image, that's already possible. And then we have a trigger to the plugin that would trigger this transformation. That could be just with a right-click, schematic from image. Now that would send the image to the API, and the API would start a process of identifying which type of information is in that image that is worth extracting in this case. So I didn't talk here about pre-processing stage, but we have, since we're dealing with the image, there's a lot of pre-processing we need to do. So for instance, removing colors, removing noise out of this image. It's always important to make the whole process more reliable. And the first step that we have after this pre-processing of the image is extracting the symbols out of this circuit. So we trained a machine learning model that is able to identify about 50 different types of symbols which are common on electronics design. Included on that resistors, LEDs, capacitors, batteries, and so on and so forth. And the first step is basically looking into that image and checking where do we have those symbols, where can we identify those symbols. And each of those symbols is then identified by their category, by their position, and also by their orientation. So we get this information out of the image. This is stored initially, so this is the first batch of information that is extracted out of the image. Then we jump into the second part, which is also very important, which is the text show information that is available on that schematic. So just the symbols, it may be already helpful, but not so much. We are also interested on knowing the reference designators of all the symbols that we have there. We're interested on seeing the values of components that are also there. So we have a different pipeline that can then go over all the text show information over the image. Is able then to extract this text show information and also categorize this in different types, for instance, reference designator, values, if you have footprint information, if you have also part number information. So we identify the position of the text, we identify the type of the text, we also are able to extract that. That is also saved for later post-processing. The third part is we have to know also how those symbols, how those components are connected together, right? So there's then a third pipeline, which is just looking into how to extract the connections among the symbols and among those components from the schematic drawing. So this pipeline is also a machine learning model. It's looking into the lines we have there, and it's trying to find out what are the coordinates, the beginning and end coordinates of those lines. And with that, we get an understanding of how those lines are connected together and as well how the symbols are connected together. Lastly, we have to create the relationships between the things that we already extracted out of the image. So if we look at the text, usually a reference designator pertains to a certain symbol. Same thing for a certain value and a part number and so on. So we need to create those relationships as well. Maybe the easiest way of doing that would be, let's just check what is closer to the symbol, for instance. That works very, very often, but not always. So we again here, we have a separate model that can look into which type of text is that, which type of value is that, which symbols are closer, and then is able to assign these properties to a specific symbol. So you can see here from the different symbols we extracted, we have small arrows pointing to the ones that are closer by that show then to which symbols those text and those properties pertain. And then with all this information, we're able to generate, we're able to create out of that a graph representation of the circuit that we were looking at. So we have here, for instance, different symbols being represented by nodes. We have the connections here, the connections between the symbols being represented by the connections between the nodes. We have also to model in a specific way junction points which have 3 or more connections. Same thing for the ones that are just vertices, so that we can keep also fidelity to the visual representation of the circuit itself, not only having it electrically correct, but also having it in a way that is that represents that imitates the way that the image was looking like when it was uploaded. And then this graph, it can be modeled in a JSON format. So there's different ways of doing that, but you can describe this graph in a JSON format. And this JSON format, this JSON format can be sent then back from our API to the target of the proposal today, which is the image to KiCAD plugin. So the plugin is installed together with KiCAD, would be able then to take this information of the graph, and the idea is that not all the information, but majority of the information that you need to reproduce that schematic in a schematic file is already available on that graph. So you can think about having, in the first step, you can think about having every node that we identified as a symbol that has also a category here, LED, resistor, capacitor, that can be mapped then to a specific symbol on the library. And this mapping can also be created by the user. That means the drawing can use the resistor symbols that the user likes the most, the capacitor symbols that the user likes the most, and so on and so forth. And by having this mapping, we can follow the guidelines that this user might want to have on their schematics design. Since we have also the position of the symbols that were extracted out of this image, we can use this information to place also accordingly the symbols out of the library that were loaded in the same positions on the canvas, on the schematic canvas in KiCAD, and also load the properties that were assigned to each of those nodes. So if we can think about a one-to-one mapping here, we have information from the resistors, from the LEDs, all being assigned already to that specific instance of the symbol. And then the last thing to do, in this case, would be to connect the symbols together. Since the symbols in the library, they may be different in sizing than what was identified in the image. This routing and the pin's position are also known because we know the library, we know the symbol that is loaded. We need to be able to connect then from pin to pin. And we can do that by using algorithms to do Manhattan routing, which is the algorithm that usually does this 90 degrees routing between two different points. And with that, we have the connection between basically all the pins, just like represented in the graph file. We have the connection in the schematic file as well. And then we have something that can be then just exported and presented in KiCAD as a schematic file. Now, what is the current project status? We have been working on this, as I mentioned before, for a couple of months now, if not about a year. We have been working on training those models. As I said before, the symbol extraction model can identify about 50 symbols up until now. We aim to extend that. 50 symbols is not enough to describe all the schematics that are out there, but it can represent a lot of them. Specifically for ICs, one thing that we identified is that we need to create always the symbol dynamically, because IC symbols are hardly something that you can map. Yeah, they usually, the way that your symbol is drawn dictates a lot on how your schematic is going to look like, and people may just draw different types of symbols for the same type of IC. So we need to reproduce that as well if we want to keep some fidelity to the original image. But that is also possible to do. In theory, we're expecting or very excited to hear that soon we will have also a interface for the EE schema for automating. So that would be made possible directly through the API. We have also other couple of issues that need to be addressed for more complex cases. For instance, when we have very high density of information, the way that we identify symbols, the way that we identify text may not be very reliable. We are working on solving those kind of issues. And the packaging of the API itself would be relatively simple, and we can make the documentation available in Swagger format, which is very common type of documentation for web APIs. And on the side of the plugin, we just basically created a repository on GitHub now, where we would like to start working on this plugin to integrate with KiCAD. And as I said, it's a proposal stage, so I'm here today basically presenting and pitching my idea to see who would be also interested on working on that. The repository is set up, and we'll be adding quite soon some example and test files so that people can start playing around with them as well. If you're interested on joining, you can scan the QR code that will take you to the GitHub page from the repository. Would be also very happy to hear from any one of you who wants to participate. So I added here some of my contact information and LinkedIn on the email. And of course, if you go through our Celus website, you also find my contact information. And yeah, basically the next steps that I'm looking forward to are hearing from whoever is interested on joining the project, and would be soon then setting up a call to discuss, how to tackle some of those challenges, how can we work together, and also set up a basic roadmap for the plugin and for the API. Yeah, that's it. Any questions?
So I don't actually see why you need anything in eSchema to implement this, because if you have this in a web interface, then you can output eSchema content into the user clipboard, which can then be pasted directly into eSchema without needing any integration on the KiCAD side.
That's an interesting thing. That's something I didn't know beforehand, so that's already very nice input. One thing that we have been working with already for a while is outputting the native KiCAD file. So if you go to a platform, when we generate those schematics I was talking about, we output natively to KiCAD as well. Now, if we're talking Clipboard, I don't know if that's exactly the same format or if it would be a different format, but that's definitely something to experiment with, because I think then maybe we can get closer to the experience I was showing on the image as well. Yeah. Yeah. Any further questions?
That's quite impressive. That's cool. I'm wondering, where did you get your training data from? Because there needs to be a lot of training data, I guess. And second question is, how confident are you in those models? So are they really useful, or do I have to recheck everything?
That's a great question. Let me address first the first question you made. So there is kind of a trade-off on how do we get the data to train the models. On one side, we invested quite some time manually labeling the information. So there's a tool we use for that, it's basically called Label Studio, where you can open images and you literally have to draw the bounding boxes around the symbols and tell what they are. And we did that for about 1,000 instances for every symbol that we have. That's why we had to limit it also in the beginning, because it's quite some work on doing that. And the other thing that we did as well was basically what is called the dynamic generation, data generation. So for the identification of nets, for instance, the model is not interested on knowing if the design is electrically correct or not. So we can basically generate images by putting symbols and randomly connecting them. We know the coordinates, and we use this data then to train the model just to identify the lines. So these are kind of things that we have to do to train the models. And there is a lot that can be extended to, but that's what we are looking for, a roadmap. The second question was, once again?
How confident are you?
Oh yeah. So again, this is a function of the amount of data that we have. Now, there are quite, maybe I can go back to some of the slides here. It works really well now for relatively simple schematics, where symbols are not too crazy, where you don't have like transformer with 4 windings one side, 3 windings the other side, and so on. That may confuse the model still. And it's a function of how much data do we have to train the model there. For more complex cases, it gets tricky. We are working on improving it. But I think that even if we would have a lot of data, it's hard to say that it would work for 100% of the times. So if we're thinking here about how to deal with the data that was created on KiCAD, I think it does need also visual verification. Just like you would do with a simulation, for instance. You simulate and then you verify that the results are what you're expecting. Here, the same thing, you generate that, you verify if that is what you were expecting. And if not all the information is available on a schematic, you may need to also add it later on. So one example here, I may load resistors on my schematic, but if the image does not contain any information on the footprint, then I will have to add that also manually. Same thing, I was talking to Joel today in the morning. If we generate the IC symbol, if we need to create the IC symbol, and we don't have the information about that is a power pin, that is a passive pin or so, we may need to add that later on. But the idea is that you already gained some time with it. So that's where we're working towards.
First of all, I just think this is an amazing idea, and I think it's got lots of potential as like a really useful component of a PCB design workflow. But I've got to say, I'm a little skeptical about the API part of it. Mm-hmm. Is the API going to be released publicly? Like, I understand it's compute intensive, but if I had the resources, can I run it on my own computer, or is it going to remain closed source?
So right now we are using even, the models are not running on our own infrastructure. So we are using external models as well, because we did have some experimentations with, with older models on doing object detection or so for this specific case. We found out that the ones that work the best are the ones that are provided by a third party. So we did use on this API this kind of models, and that means even if you would have if you would have the resources to run it, some of the models are not even run by us. So it would still be like a bypass just to other separate models. So we don't plan for now, at least, to make the API open source. For this reason as well, we're still working on the project, but that's the reason why we opted for going with an API and not just having like everything running on on-site, on-premise, for instance.
Okay, thank you.
Hi, thanks for the talk. I have like two sides. My question is coming from two sides, kind of. Mm-hmm. First, when I saw this mock-up of how this would function, you have the schematic and you just paste it in KiCAD. That's super cool, I think, in principle. On the other side, I kind of wonder still this 40% number. Mm-hmm. For me, it's like I'm doing a project right now. It's 95% engineering, 5% schematic capture, and that schematic is one I need to come up with that I will not find in any place anywhere. So I don't want to question the general, if there are applications, there are. Certainly the demo is super cool, but that's the first side. And then there is like, parsing for pinouts. Mm-hmm. When you have a connector or IC, and you can do that with OCR, like a basic thing. That's very common, I feel. What's my question? The question is how you perceive the practical side, basically, of this, what applications you have. Second part, question more like in the general round, I wonder how this is well aligned with the mission of KiCAD, because of this AI thing. That's something people in my circles, at least, are very opposed to, and also this API thing, they wonder about this. So, maybe you have some response to that.
Mm-hmm. Maybe just to address the 40% number that I talked previously, that is a number that comes out of our teams, the way that our teams work. And the thing is that for our platform, we need electronics content. That means digital schematics. We need also partially PCB layouts. We need to classify the circuits. We need to enter the parametric information of the circuit. So for this type of work, which our electronics engineers are doing in-house, for this type of work, 40% is going to schematic. So that means we're not going to the test bench, we're not doing EMI measurements, we're not fixing, the EMI measure things that comes out of the chamber. So I think that there's a lot more to the work of bringing a product to the market. This is not represented on what our team is doing necessarily, but the project the initial idea of this technology, it came out of our internal use case. That's why I wanted to bring out this number, 40%, because for us it's very representative. If we're able to do that, we're able to save a lot of time on creating the content that our platform lives from. Now, concerning the point of the pins of ICs, I'm not sure if I understood correctly, but if it is about understanding the pin naming of the ICs and creating the symbol, did I understand correctly? Yes. Yes. So I think that we can extract information that is in the image. We can create that symbol, for instance. We can put the information that is there, but not all information that is relevant for the schematic will be in that image. So that portion of the information, it needs to be added then to the project later on. And the part of the idea of how does that fit to the KiCAD mission. So what I wanted to bring here and present to everyone today was an idea that would help every electronics engineer to be a bit more productive when they are working on the transfer the schematics from an image. That's what is provided by component manufacturers nowadays. Some of them provide Altium files, Eagle files, but definitely not for all platforms, because that takes a lot of time for them to do as well, and they don't have all the licenses also as well. So one way of transferring that to the canvas and saving time with that. So I think it would be like a productive tool for all electronics engineers. And why I wanted to bring it also specifically to this KiCAD conference is because I already talked to a couple of people today in the morning. I think the possibility of having plugins in KiCAD and having extensibility in KiCAD is something that you don't find on every other tool out there. And I think this is one of the main strengths of KiCAD as well, because you can bring a lot of new things that the community can develop as well to this tool and make it a great tool. So that's the idea I wanted to bring and pitch to you guys today.
Hi, thanks for your talk. I have a special question about how you treat uncertain detection cases in your output. Would you flag it? Would you throw output warnings? Or how would you alert the end user to have a detailed look at some place of the output?
Yeah, that's a great point. So we thought about having like a standard symbol. So we can set basically a threshold where we can say we're certain here that this is, I don't know, it could be 70%, 80%, 90%. It's a value we can set on the pipeline. Above that threshold, we can consider this certain to be that symbol. Below that threshold, we could say we're not sure. It may be a resistor, it may be something else, maybe also a rectangle. For example, rectangle resistors and inductors are sometimes also mistaken for each other. So we can export that uncertainty as well. And I think that there are different ways of treating that. One would be, or the most obvious would be, we just set a standard symbol that the user sets there, and then everything that we export that is uncertain, we use that specific symbol. Another thing would be to match the information of the symbol detection with the information from the other detection pipelines as well. So if we're not sure if it's a resistor or inductor, but the OCR identifies that close to that one we have R1 or L1 reference designator, then that may help increasing this certainty level. So this is more like on the part where we connect all the information together to generate the graph. These are a couple of different ways of handling that. But again, that would be something we can then discuss and see how to make this the best way for everyone to be more productive.
So I recently had this issue where I swapped in a feedback network a capacitor and resistor and blew up a circuit. And it would have been really useful at that point to go like, here is the schematic from the datasheet, and here's my schematic. Is it right? Is there a way to sort of feed back a KiCAD schematic back into this and compare it to an image?
I think that this would be a very interesting extension to what I'm proposing today, because if we're thinking about a graph, right? You could have then the source that you've drawn yourself, and then you have the source from the datasheet, and then you can expect to have at least some coherence between both of them. So it could be thought also as a way of verifying what you have drawn and not only just pasting it there. I didn't think about this use case before, but I think it would be also really cool to have something like that. Yeah, definitely. And I think it also would be possible.
Okay, thank you very much.
Thank you.